right. Good morning, good evening, good afternoon to you all. My name is Gloria. I'm part of the GetCoin team. I'm here with Nicholas from Reach, and he's going to give you an introduction to the intro to Reach on Algorand. Before we get started, I wanted to say that this session is being recorded, so feel free to rewatch this session. You can find it live on the GetCoin Media page on YouTube at GetCoin Media. There'll be a playlist that's the Algorand Hackathon, and that's where you will find this session and all other recorded sessions as well. Second of all is if you do have any questions, throw them in the chat or the Q&A. I'll monitor both. And last but not least, in the chat, feel free to say hi, let us know where you're watching from and what you're working on. It's a good way for us to get to know y'all and a good way for y'all to get to know one another. With that, I'll go ahead and hand it over to Nicholas and he can get started.
Thank you, Gloria. As Gloria said, my name is Nicholas Stanford. I am the Developer Experience Lead at Reach. And today I want to talk about a little bit of intro into building applications on Algorand with Reach. So we'll do like a brief overview of what is Reach, and then we'll walk into a basic code demonstration. We'll look at the scaffolding of a Reach program and connecting to the Algorand network to actually run our code on the Algorand network. So how can you learn Web3 in less than a year and build dApps safely? Spoiler alert, Reach is the answer to that question. And why do we say that? What is Reach? Reach is a programming language, a compiler and verification engine, and a deployment tool. We say that Reach is an entire blockchain development platform, right? Because of these three key pieces. The programming language has a familiar syntax modeled from JavaScript. The compiler comes with formal verification engine. And what is that? Well, the verification engine creates some mathematical proofs and theorems based on your program's logic to secure your smart contract against vulnerabilities or flaws. We'll get more into that later. Third, the deployment tool allows you to actually deploy your code to different blockchains. In this case, the Algorand blockchain, right? So Reach is a platform to develop our decentralized applications. With minimal training, a full stack developer can write these decentralized applications with Reach. And most developers are ready in like 3 to 4 weeks, right? How do we actually build these full scale applications, right? Well, Reach compiles and verifies our code to produce the smart contract. Then Reach actually deploys that to the blockchain network. So you see here in yellow in the center, we are developing an application that outlines how our users use that application. How do participants interact with our application? And then Reach breaks that down and creates a smart contract. It actually creates teal code, right, to send to the network, right? So after we deploy our smart contract, the contract enables our participants and different types of users to interact and complete transactions on the network. When I say participants, I mean logical actors that participate in the dApp and they're associated like with an account on the network, right? Like a wallet address. So when we say consensus network, we just mean blockchain. Again, the Algorand blockchain in this case. As Reach grows, we'll continue to support more blockchains. We'll be able to deploy to more blockchains through Reach. And it reduces the need to understand that difficult low-level programming language like Teal. No longer do you need to write stack-based execution language to actually create your smart contract. And you would have to build out all these verification pieces yourself, right? You, the programmer, would have to write all of this code in that says, guarantee it works this way, right? Reach does all of that for you. So let's break down the steps of actually creating that full dApp. We start by defining our participants and their interactions in our Reach file. That's index.rsh, right? RSH is the Reach extension. So we define those participants and their interactions, and we call this the participant interact interface, right? It's an interact interface. It's where the user is actually, what functions are we allowing the user to use, right? It contains the methods and values that the user can access. Only that user can access those methods. Again, this is done in our index.rsh, and that's our backend file. When we say reach is a full stack setup, right? So we have a backend and a front end. So after we define our participants and their interactions, we move into the communication model, right? And this is directed by that participant interact interface. How are participants actually communicating with the contract? Reach developers do not write smart contracts. We build programs that focus on how the participants will interact with the smart contracts interface, and then Reach compiles the program into a smart contract on your desired network. So we compile our program. Index.rsh is compiled to produce this new intermediate file. We call this index.main.mjs. It breaks down intermediately into the build folder in that index.main.mjs. Okay. And then we compile that to produce the bytecode for our consensus network. Again, Reach on Algorand actually breaks that index.main.mjs down into teal code to send to the network. And I'll show you that output of teal code from the Reach here in the demonstration. So next, the verification engine, very important part of Reach. This is where the security comes from, the security and safety of these programs. You don't have to write tedious, long verification checks in your programs. You can just use Reach verification engine to confirm what you assume is true about your program. If you have a function that you've created the logic for that you believe works some way, that's great. And usually you write tests for that and you test at all the inputs and the outputs. What if you could just tell Reach, here's what a win looks like. Here's what the function should do. Can you check all possibilities for me? That's what the verification engine allows you to do. It also comes with some like standard checks that we run for every program. And that's based on the logic, but you can also include custom checks. You can customly check, is my function operating the way that I expect it to? And are users protected? Is my contract protected the way that I believe it is? We'll cover a little bit more about the verification engine here. So then we move into the front end, right? So we've compiled our RSH file. We've got that index.main.mjs. Then we run the verification engine. We turn that into the actual bytecode, right? And then the user has their front end. Standard sort of Web 2 similar front end. And in Reach, these can be created with a number of different languages. We're going to show you JavaScript. All of our tutorials show JavaScript, but you can use any other language with our RPC server. If you like Python, you can use Python. If you like C#, you can use that. If you like Go, many languages are supported via our RPC server. So the developer creates that front end, and that front end is actually what interacts with the contract. Right? The front end mirrors the back end. Why do we say this? I'll show you more when we get into the code. But we say that it mirrors the back end. We use the same function names in the front and in the back end. And this image visualizes how the compiled Reach program actually reflects the back end. It's that interact object. Any piece of information that you've declared in the back end, if you have a constant that you're calling wager, you need to have that same wager declaration in the front end. And that's why we say that it mirrors it, right? So the next piece of Reach is the JavaScript standard library. This provides support primarily in the front end and can send some information to the backend for us. The Reach standard library has a lot of helper functions, and in the demonstration, I'll show you a few of them. And in the lesson that I go through tomorrow is the extended lesson, and I'll actually cover a lot of the more advanced features of the standard library and of the Reach language in general. So here we're showing the account, the address. How is the user interacting? And we're using the standard library to sort of assign that account and say that this account is this participant. When I say account here, it's interchangeable with address. They are basically the same. So it refers to an account that can also store value, right? The contract itself is an account. The contract can receive tokens. It can pay tokens, the same as any other account could, except that we're controlling it via the logic. Next, the full overview of a Reach application. You have your index.rsh backend. You have your front end, your mirrored front end here, that index.mjs. And then you have your standard library. And this interacts with our DApp. This is how our participants interact with our application. Right? So again, our DApp uses that account to actually access the consensus network. It's like your personal window into the blockchain. Your account is unique to you. And we don't have a database of your name. We don't have a log of users anywhere. We're not tracking who is who, but we can use that address to uniquely identify our participants. That's how we tell who is who. Right? So after we've got all the pieces in place, and we actually compile, we deploy our contract to the network. When our program's complete, ready, we have a deployer. We have a user who comes in and says, this contract. And then it launches an instance of that contract. And that instance lives inside of a transaction block. That's our little graphic there. You see contract deploy, and it's moving itself out into a block. So the network includes that smart contract into that new transaction block. And now it can be referenced from there. So now our participants can actually interact via the smart contract. It lives out on the network. They can call functions. They can make transfers. They can do anything allowed by the logic of the smart contract. So that is our brief overview of what it looks like to build a full stack application, a full stack decentralized application with Reach. So next I want to walk through a little bit of what the install looks like. What are the requirements for you to install Reach on your machine? And then also show you a little demonstration about the scaffolding of a program and also some of those standard library helper functions I was describing. So here are the install instructions. That links to a page in the Reach documentation that I should also probably drop here for you. So that's the quick start page for Reach. It'll bring you to a few of these requirements that we'll discuss. So installing Reach requires make, which you probably have on your system already. You can just run a simple command at the terminal, make version, to check if you do have make. You need an instance of Docker. Docker helps us to create containerized environments that we can, in our local DevNets, create a simulated blockchain, right? And then allow us to actually run our program there as opposed to launching to the full-scale testnet. The next thing is the VS Code extension. Reach has a custom VS Code extension. This will help with the syntax sugar for your programs. If you want to go to the extension section of VS Code, we recommend VS Code because we have this custom support. You can go into the extension section and just search for Reach, and you should be able to find the Reach extension and go ahead and download that as well. Reach is designed to work better on Linux and Mac systems than it is on Windows systems. So if you have a Windows system, you need to also install WSL2. You need to create a Windows subsystem for Linux inside your Windows environment. And this will allow you to actually install Reach in Linux, right, while still maintaining your Windows system. This is how I run it. Personally, I've had Windows my whole life, and I guess I'm stubborn. I have a hard time getting away from it. So even programs like this that require a couple extra pieces, I don't mind. Maybe it is because I am stubborn. So those are the requirements for installing Reach. And the next thing I want to look at are just a few of the scaffolding, or like the common commands you're going to use, a few of the things you should get really comfortable with. Reach init, the top one here, is actually going to initialize some skeleton code for you. If you run Reach init and then pull open the two files that it creates, it'll show you the basic structure you need to run a Reach application. After that, you can run Reach compile, and then you can run Reach run, and you'll actually see some output. It doesn't do anything fancy, but it is the scaffolding that you need. And once you start to build more Reach applications, you'll really start to like this, because you can just, /reach init, pop up the two files you need, and it's got some skeleton code for you there already. If you're learning and really hoping to learn the fine details of Reach, I recommend building the scaffolding yourself a few times. Get comfortable with what that looks like, and then you can go ahead and when you're comfortable, switch to using that tool, that Reach init tool. Reach compile, this will run the verification engine for us. It runs a standard compiler like we're used to, but then it also checks any verification theorems that we have. So become familiar with that one, you'll need it. Reach run allows us to run our local dev nets, right? So anything inside a VS Code terminal right there, it allows us to run our programs right inside of there. And then Reach update. This is important because Reach puts out updates to the language every 2 weeks. So that means every 2 weeks, you'll need to update your Reach version. And this keeps us from having some strange errors we may not be familiar with, because they may be specific to an older release, and we don't see a lot of those errors pop up. If you help keep your Reach version up to date, you will avoid a lot of those errors. So the last thing I want to look at is the modes of a Reach application. These are the different steps that our application will actually go through. These are the pieces that we need to be very comfortable with, because we're going to our functionality is actually going to create the custom path that we weave back and forth between step, local step, consensus step. What are those? Let's start with app init. Remember, I said we define our constants, and then we step into our program. So we define the data that we use, and then we start stepping into our program. After we define all of our data, we use a special Reach function called init, and we just type init there right after the data, and it starts the actual program action. The next is step. When I say step, you can just consider it state. What state of the program am I in? This is like general state. These other two are a little bit more specific states, but step itself is just general program state. So from step, I can ask a user, give me some information, input some information. Maybe it's a number, maybe it's the number 5. So local step is between the user and their machine. It's the user at their keyboard inputting some information. So that's what it means to be a local step. And then we send that local step information to consensus. We send it to the consensus step, where we publish it to the blockchain. In the consensus step, you'll start to spend gas fees, transaction fees, the 0.001 on the Algorand network we're all familiar with. The consensus step, generally everyone agrees in this portion of the program on the state of the program. So anything that needs to happen in regards to the blockchain, we actually need to write information. We need to pay an amount. We need to retrieve some information. Like that is all consensus step. Okay. I'll talk more about those as I get through them, but let's look at an actual program and see what we can run. So this is my VS Code window. I've got the Reach extension installed with a few others here. Yep, down here at the bottom, you see Reach extension. So this is what you'll need once you get into VS Code here to get the syntax sugar for these programs. And then I'm going to pull my terminal open and we'll just call it green. So I need to create a folder. So I have Reach installed. If you work through those install instructions, I'll show you where it's at. It's here. That's this green Reach folder here. So I like to install it one level down. So if you CD back up to the home path, you're at like Linux home, and then you create a folder called Reach, and that's like your top level, right? So you say this is my Reach level, and then I CD Reach, and then install here. Because what that allows me to do, again, I'll show you what's in here, is all of these different files are my project folders. Each one is a different project. So if I want to make a new project, for this course here, let's say make directory green, and then we're going to CD into the green folder. And I want to show you first what this Reach init tool does, and then we're going to build some of that scaffolding ourselves. So if I say ..reach init, it's going to create two files for me. It's going to create index.rsh and index.mjs. Remember, RSH is the backend, MJS is the front end, right? RSH is Reach code, MJS is JavaScript and the JavaScript standard library from Reach. So we have these two files in here now. Let's pull them open and see what they look like. So if I called it green, that's going to be up here. So here are my two files, RSH, MJS. So these are the two different files that you'll need to build your Reach application and run it right here. So here is the data definitions that I discussed. Right? If you had some number called a wager, you would declare here that it's a wager and it's a UN. And then here is that init, where we're actually stepping into our program. We're actually moving into the state of our program. And then the next steps for our program in this very rudimentary boilerplate application is just an empty publish, move me to the next step, another empty publish, and then another move me to the next step. So commit is sort of our way of saying, I'm done with all of this consensus. Now I'll move me to the next step. Remember our graph, our modes of a Reach app, it allows us to move back and forth between step and consensus step often. So what does this program actually do? And I'm going to remove this so it actually runs. And let's run it. So if we say, get me back into that folder, Reach compile, it's going to tell you, are there any errors in your RSH file? Compile just checks your RSH file, your Reach code. We see that the verification engine runs at compile time. It checks for any knowledge assertions, anything we've told it, it must check for, and then it checks for those standard basic verification checks that it has. It says it checks 5 theorems and there were no failures. Okay, that's great. So now we need to actually run our program. But remember, Reach is compatible with different blockchains. All of this code can be sent to different places. But if we want to tell Reach, hey, this is for Algorand, we say export Reach connector mode equals Algo. And now it knows, okay, point to Algorand and give me teal. And then we say /reach run, and now it's going to give us some output. Remember, this is just a boilerplate program, so I just want to show you what some of this output is quickly. So this is the Docker, this is us creating a new Docker container, right? And then this is us actually moving into our program. So anything after node here, that is the start of our program. So the output starts after this. So you'll see a couple warnings here based on us testing in our DevNet, and then you'll see hello Alice and Bob, launching, starting backends, goodbye Alice and Bob. So what we've really done is we've created the structure and allowed our users to attach to our contract, to join the contract, fulfill the 2 roles that we've assigned, and then actually output some information. So those are just console logs. There's nothing fancy happening here. And I'm going to give like a quick rundown of how we would build like the intro level rock, paper, scissors, and so that you can look at some of the actual data as I pass it back and forth between the front and the back end. So let's do that. So let's exit. And then we're going to rebuild that. We're going to rebuild this too. So let's go into our RSH. Remember, this is our reach code. So at the top of every reach file, we need to tell reach what version we're dealing with. We're dealing with 0.1. And then we need to define the data. Remember, the data definition is the first thing you should do. I mean, problem analysis should probably be the first thing you do. You know, what you start thinking about your application. What do I actually need? And it may be good to kind of draw out a diagram or draw out a state diagram for what your program needs, what data you need. But I've written this program a few times, so I know what data we need. So the first thing we're going to do is actually write some of that data. If this is a game of rock, paper, scissors, there are certain functions that we need to have, and there are certain pieces of data we need to have for this to run. So I'm going to create the actual export for the reach app. So if I say export const main equals a reach app, this is the actual guts of my reach application. So we'll build everything inside of here where we say, okay, if there are 2 users, right, there are two players playing the game, and we use Alice and Bob here as a common cryptography name. So we'll say, okay, well, the first person is going to be called an Alice, and they are a special type of user in reach that we call a participant. And this just allows them certain functionalities. There's a lot underneath of that we can get into at a later date. Tomorrow's lesson would be good for that. So we've created Alice here, and we're saying, okay, we're gonna say this person is Alice, and then this person is Bob. We create a participant here. And we say Bob here. So now these are the specific areas of which Alice has those specified methods and data instances. Remember, we said that we can keep the data only available to one user or to all of our users. So how do we actually go about that? So after this is after our data definition here, we want to do, remember what I said, we want to init. Right? So if we have functions that are shared between 2 players, we can do that in a little bit of a special way. We're going to create a player object, and it may be easier if I just call this shared, right? So let's call it shared. We're going to share these functions between both users. So first one we need to have is called getHand, and this is just the function signature. This is just the signature of the function. Give me the name of it, tell me what it is, and tell me the inputs and outputs. What are the data, what data is coming in and out? Not specifically pass me in an argument. Tell me, is it an integer? Is it a string? Is it null? What is it? So we'll say getHand is a function. That's the name of the function. We declare it like that. We say, okay, that's function. It takes in no arguments, and then it returns an unsigned integer. We're going to use integers to represent the different hands, rock, paper, scissors. So that's why getHand is going to return it in. And then the next thing we need to allow our users to do is to see the outcome. Seeing the outcome takes in an unsigned integer, and it returns null. So now we have this shared player object, this shared object that we need our users to inherit. So both of them get to do this, we have to say, okay, give me everything. Oh, I'm sorry, I'm having trouble typing today. So we'll say, give me everything from shared. So we say dot, 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 shared for Bob. Now, both users have access to these functions. We've declared the data, and now we've initialized our application. So let's move over into JavaScript, into our JavaScript, and start building out some of what that looks like. So remember, RSH is reach code, MJS is JavaScript. So inside of our JavaScript, we need to do a few imports first. So the first import you need to do is loading the standard library. And you see it has a little helper there. I'm going to cheat and use that. And it says load standard library from this location. And then we're going to do the same thing. We're going to import, but this time we need to connect the front end to the back end. Which file are we actually talking about in this front end? So we say import everything as, and here's our identifier, backend, from /build. Oh, I'm sorry, that just kind of flies over there. /build/index, right? And it's telling us index.main.mjs. Remember, when we compile our program, we compile this RSH file, it turns into index.main.mjs, and it comes from the build folder. So we'll take a look at that once we break this code down a little bit more and actually compile it. But then we create a constant to easily reference what we're saying is load standard library. And then we need to create a couple of users. We need to create users who are actually going to interact with our contract. This is specific to our testing. In a real world scenario, we're going to get the user's default account. We're going to allow the wallet interface to trigger and say, tell me who this person is. And they sign at their wallet interface. And remember, the address is how we identify users. So how are we going to create test users without a wallet? Well, we have a reach standard library function for that. So the first thing we're going to do is store that account in a constant. We'll say account Alice. And then we're going to await the standard library to create a new test account. And you see there's a couple options here. There's a singular or plural. We're just going to do one. New test account. And then we're going to say starting balance, right? It takes in an argument for starting balance. Now, we don't have that declared yet, but I'm going to show you that here in a second. So if I say const account Bob and create my second account, I do it the same way. Standard library.new test account, and then pass in that same starting balance. Now, where is starting balance coming from? So let's give it starting balance, right? So we need a const starting balance equals what? If we want to say 100 algos, we can't say that. The network speaks micro algos. The network deals in micro units. So for us, the programmer, and we don't want to have to hit the calculator every time that we want to pass 100 algos into a function. So we have a standard library helper function called parse currency. So we're going to reference standard library.parse currency, and we're just going to say, I, the programmer, want to input 100 algos, and I want you to parse that currency down to micro algos, so that when we send starting balance to the blockchain, it's in micro algos, because the network deals in micro algos. Every time you deal with algos, there's somewhere it's breaking down to micro and then sending back up to return to you. So this is how we send our 100 down to micro units. And now we're going to do a little bit of contract housekeeping where we say CTC Alice. So this is specific to Alice's contract info. And we use the account. Remember, that's how we identify our users. So we're using the account, and then we use a reach helper function called contract. And what does the contract actually take in? It takes in an argument for a contract. Where does that come from? Well, it's right here. We import it, and we said that our identifier is called backend. So now if I want to say, okay, account of Alice, go to this contract, I say account Alice.contract, and then I pass in backend. And now the CTC Alice constant holds unique information about how Alice actually interacts, or how Alice is connected to that specific backend. So in that same instance, how do we get Bob attached to Alice's contract? There could be different instances of the contract. We want this specific one. So we'll say const ctc Bob equals, again, we'll use Bob's address here to reference him, that same contract function, but now it takes two arguments, right? These are optional arguments. It takes an argument for which contract are you talking about, and then specifically who else is involved. Well, we have ctc Alice to reference Alice's unique identity to this contract. And then we have a helper function here that we say is getInfo. And this is going to return the information about Alice's contract and tell Bob that, okay, the backend that you're trying to attach to specifically declared for Alice, and store that in his contract information. Okay. So next we'll come down here and say, we'll actually create the automated test here. This runs a little bit differently when you have interaction, when you have actually people coming in and doing these things. But what we're going to do here today is just automate it. I'm just going to let the program run itself. So we're going to await, and now we need to actually invoke that contract information. We need to use that contract information and send it a participant. So if we have ctc Alice here, .p just stands, it's short for participant. So .p, and that is an Alice. So we're going to create this interact, and we call this, we touched it a little bit in the presentation, but we say that this is the interact object. This mirrors the backend. Whatever's in the backend interface, the interact interface, has to mirror this interact object. So that's it for Alice. Let's do it again for Bob. ctc bob.p.bob. And then there will be a, we'll just say Bob interact object here. So now those are the two different users and how we're going to automate and sort of specify who is who, and then how we actually run through the program. So we've defined what our data, we've got like our basic structure in place, that scaffolding is in place. So now let's actually start to build that rock, paper, scissors program. So we need a few helpers, right? We need a few pieces of constant information to help with our computations, right? So we said that we're going to use integers to represent the different pieces, which means that we can use arrays to represent the different hands. So we can say rock, paper, scissors. And then we also need another one to determine what is the outcome of this. And it's Bob wins. There are three options. Bob wins, there's a draw. And then there's also the option that Alice wins. And then we have this shared player object back here. But remember, this needs to mirror the front end. So we need to come in here and build that same thing. We need to say const shared. And then we're going to give it one parameter, who is calling. If we're going to allow different users to call this, we want to know who called it. So we're going to send in one parameter. And now we need to actually define the same function signatures that we use right here. Right? This is the function signature. This is the declaration. And on this side, we're actually going to say how it functions. What is the functionality it has? What actions does it actually take? So we call it shared. We pass it in one, and then we look at what our first function was get hand. And we said it took no arguments. The backend, we've already declared this. It takes no arguments. And now let's see. It returned get hand, returned a UN. Okay, so on the front end, this needs to return some UN. Whatever it is, it needs to return some UN. So in this case, we're going to automatically generate a hand. And this is the math for automatically generating a random number between 0 and 3. And then storing it in a variable called hand. And then we're going to console.log. We're going to say, who, right? That's the parameter we're passing in. And then we're going to also denote which hand they played. So this part, I want to be very clear about what's happening here. So this is just your string, right? Your log string, and then here's where we're inputting our variable. And in this one, if we want to just put out the number, we would say hand. But if we want to reference the string array, we want to reference the array of strings, we would use hand, right? We've called it this here, and then sub whatever you get for a number, give me that hand, right? So now this allows us to output a string, but send a uint to the backend. So now instead of uint, we'll actually just return hand. Oh, not that one, the lowercase one. Don't forget your end of line characters if you want it to look nice and clean. And then the other function we had was see outcome. So let's also create a see outcome function. And what was the input? It was some uint, I believe. Yep, here it is. Input some uint, and then return null. So we'll just call it the outcome because we're going to use a number for that as well. Imagine that. We use a lot of numbers in programming. So see outcome. And what do we want to happen here? We just we want to log something to happen again. So we'll say who, right? The person that we passed in saw the outcome, and then we'll actually send it the outcome. So just like we did with the hand, we're gonna give it the brackets it needs to say, okay, here's a variable, and then inside of there we're gonna reference the outcome array and pass in whatever outcome is, right? And these are locally scoped. Like if you wanted to call this K, you could call this K. You could call it whatever you want in this local scope. But I think it's good to keep it as outcome so that when you read it, it reads like what it actually does. Once you get a lot more comfortable, you can start calling your variables and constants whatever you like. So now we've defined the front end mirroring the back end, right? We've got that shared group of player functions that's mirrored on both sides. And then we had one more piece in each user's interact object. Your interact interface here in the back end is this that we actually inherited that. So we need to come down here and actually do the same thing, right? We need to say dot shared, but this time it takes in who is calling it. And right here, it's like that's Alice calling. So we'll let Alice call that one. And then when we come in here, we need to say dot shared, and then we'll let Bob be this person. So now we've actually mirrored that user's interact interface, and we've mirrored that shared set of player functions. So next, we need to actually have the user get a hand. Excuse me. So we need to actually have the user get a hand. We defined our data up here, and I said that init is app initialization. It allows us to start stepping through the steps of our program. So that's where we need to actually say, okay, Alice, go get a hand. And we're only allowing Alice to do this. That makes this a local step. I showed you that graphic, local step. Why? Because here at Alice.only, Alice is retrieving some information or adding it with her keyboard. Alice is at the keyboard, putting in some number for a hand, and we're going to take that information and then publish it to the blockchain. So we say, okay, Alice only, go do this thing. And what this thing is, well, we know what the function's called. We want her to get hand. We want to say get hand. But we can't just say it that way because it actually lives in the front end. The functionality lives in the front end. So we need to say interact.get hand. Now that'll go to the front end and grab it, right? This is going to return some value, so we want to store that in a const. We'll call it hand Alice. And the last piece of this is that when that information comes over from the front end, it's actually hashed. We need to unhash that information so that we can actually use it. So we say declassify, and that will actually allow us to view what is under that hash, right? It comes over from the front end hashed, we clear that out, what's underneath of there, and we grab it and store it in hand Alice. And then we need to tell the blockchain about it. We need to say alice.publish. Remember, publish is a consensus operation. It sends information to the blockchain. And in this case, we want to send it hand Alice. We want to say, okay, here's the hand that Alice selected. And then we commit. Remember, commit is I'm done with consensus operations, move me into the next step. So now Alice has actually committed. We've committed to that information. We move to the next step. And the next step is for Bob to get a hand. So we say Bob only. And then we do the same thing for Bob. Use the same function to get hand, and then he also has to publish it. So this one is const hand Bob, and that equals, remember, we have to declassify. We have to bring it over unhashed. So we say declassify, interact with the front end function that I'm calling getHand, and return that value. When that value returns, it'll store inside of hand Bob. So what do we need to do with it then? We need to say bob.publish, send this information to the blockchain. Oops. Moving too fast now. So that's how we get information from the user, and then how we publish that information to the blockchain. I wonder what the error is telling me here. Oh yeah, I don't have exit in there yet, so that's not a problem. I'll get to that later. I guess just to make it happy, we could say exit. This is how we destroy the contract. This is how we terminate our application. And we can't do it in a consensus step. It actually wants me to commit first. So I'll come down here and just add that, just to make Reach happy. But it's telling me, okay, now consensus operation, I need to be in step before I allow you to exit. So that's why we have to add that commit. Okay, back to rock, paper, scissors. Both users have hands, and now they've published both of them to the blockchain, and we need to determine what the outcome is. So we're going to say that const outcome is, and this is just a little math to determine, based on whatever hand was selected, who won the game. Now, if you're not comfortable with this math, I recommend writing out all the options and then working through each of the possibilities to determine and verify what you believe the outcome would be, and then it references the appropriate number. So it's going to take Bob's hand, and it's going to subtract that from 4. Whatever's left, add that to hand Alice, and then modulus 3. So if that number turns out to be 5, that mod is only going to return the remainder. It's only going to return 2. It's whatever's left over. Send this number in, divide by this number, give me whatever's the remainder. That's what I want, is the remainder. So this math will work out each time that a user selects a hand, and it'll work out to give us the appropriate winner based on that hand. So that is the actual interaction. We determined our outcome, and now the last thing we need to do is actually show it to our users. So we say each, and this just creates a local step for both users. So we're saying each Alice and Bob go do something, where in this case something is to interact with the front end function that we are calling coutcome, and then pass it in that outcome constant. So now we have our rock, paper, scissors game, and as long as I didn't make any mistakes, it should actually run. We'll compile first just to check to make sure there's no errors in our RSH file. Not a problem. It's probably going to tell me that I didn't export. Yep. Export for each connector mode. You can also set this in your config file. I don't like to do it for demonstrations just because I like to remind you that it's there. So we'll build out a little bit of our Docker. We'll get to node experimental modules, and then we'll get an error here. Okay, so I already reached compiled, so I knew there's no error in my RSH file, but it's telling me file index MJS on line 31, share is not defined. I think I misspelled it. I must have misspelled it. I'm missing a letter. See, it doesn't like that. You got to have the D. Got to have shared on there. And then you need to save your file to make sure that you're running the most recent. So a little bit of live debugging there too. We'll clear that out because we know it's right. And then we're just going to reach run because I know the RSH file is good. And then it gives us automated hand, right? It picks a hand automatically. It says Alice played scissors, Bob played rock, and then both users saw the outcome. Why does it show that twice? Because remember, that's a local step. That's between the user and their computer, and what the user is actually seeing on their screen. So while we've put it both on the same screen, in a real application, this would display on 2 different screens in 2 different parts of the world. So a few of the last things I want to show you are the actual underlying sort of pieces. So if we say reach compile intermediate files. I think I got that command correct. It'll tell you if we didn't. And then it'll come over into here. And remember we said that the compiled file ends up in this build. So you have build here. And now it's reaches out, outputted all the extra code that it creates based off of what you just inputted. So first I'll open it index.main.mjs. And this is the middle step. This is the JavaScript that Reach compiles all that down into JavaScript before actually compiling down to Teal. So here is the JavaScript that we did not have to write. I guess I just want to look at, see, this is 35 lines of code. This is 35, so that's 70 lines. This index.main.mjs goes on and on and on and on. I think it's 440 lines of code. We wrote 70. Now, what about after that? What's after that? Well, there is somewhere in here, let me find it, that we can actually look at the Teal file. So here are the Teal files that are generated. This is the stack-based execution of Teal. So Reach actually took your code from here, from this RSH file, broke it down into this file, into this JavaScript file, intermediately, right in the middle, and then it says, okay, you chose Algorand, here's what that looks like. And then it outputs the Teal code. Now, you don't use this code. This is just for demonstration purposes. You should not come in here and modify this in any way. But if you needed to actually output that file for, say, for auditing purposes, you can easily say, okay, here's all the Teal file. And an auditor could look at that. But it's also good for demonstration purposes to show the Teal that you did not have to write. And this too continues on significantly. So that is the power of Reach, right? We get away from the low level, meticulous language, and we move up in layers of abstraction to make it more convenient for us to write more robust smart contracts, more robust decentralized applications, because we're no longer requiring you to load instruction on a stack and remember which memory allocation you have for it, which memory space is going to. None of that is required, right? We've abstracted all that away, and then the Reach language is really well built for decentralized applications. That's the entire focus of it. So now you're up into this high-level language that has a familiar syntax that allows you to focus on the details of your program, the business logic of your program, and add extra functionality on top of it, right? You don't have to spend a lot of time worrying about the ones and zeros. You spend more time building cool blockchain applications with more robust features. So that's why we use Reach. That is the demonstration that I have for this morning. So if you have any questions, please feel free to drop them in the chat there. I'd love to answer them. Otherwise, please join us in the Reach Discord channel. We have lots of Reach community members who love to interact and answer questions that you have while you work through the hackathon if you have any issues. So that's all. Thank you.
Yeah, thank you, Nick. Again, if you do have questions, throw them in the chat or throw them in the Q&A or reach out on Discord. Nicholas, can you, I know that you had the QR code before for the Discord, but is it possible to put a link in the chat or show the QR code one more time so that people can scan it? And
yeah, let me pull it up. Let me pull it up there. So this is install instructions. Let me believe I have a good one here, I think. This is all the presentation we didn't get through today. So here's the good one, if you want to use this one, and that'll help you join the Discord channel. We're always in there. I mean, it's one of my big jobs is to spend a lot of time in there and answer troubleshooting questions, clarify any points about Reach. And let me also grab another link too.
And I know the developers are really helpful in the Discord, but also their docs are really, really well written too. At least
Yeah,
that's usually.
that's our goal. Everything should be somewhere in the docs. And a lot of times we'll get users that ask questions and we say, it's here in the docs. And like, well, can't you give me an answer? It's like, but it's described best in there.
Yeah, I feel like going through the docs is usually the best way to learn too. To learn through like going through documentation and trying to see if you can figure it out by yourself first, and then if not, you know, kind of rubber decking it with somebody else helps so
Yeah.
well. But like usually, if you've gone through the docs, you can at least say like what was unclear in the doc, or or what needs to be rewritten in the doc. But yeah, that's usually a good starting point. So.
Yeah, and we love feedback on that too, because Reach is a newer language. Like in the span of programming languages, we're a pretty new language. So we're still learning the things that our users want to see in the documentation. We're still here taking feedback, and we're updating the documentation every week. And then also, if there's some section like, oh, this didn't make a lot of sense, like our goal is for all of that to make sense at the first read through, or at least all of the information be there for you to digest and be able to actually get it to make sense. So what I don't want is that the documentation's out there, users read it and they say, well, I didn't get it. And then you just never reach out, right? We want to fix that. We want to help you understand that. Again, it's part of my whole job. So.
Yeah, I appreciate that. All right, cool. And I know that we have people from multiple languages watching and participating with this hackathon. So if you speak another language and you can help, with docs to navigate it for other people that also are multilingual or speak other languages, that just helps the community to grow even more. So, take a stab at that as well. Other than that, Nicholas, I don't want to keep you too long, or I don't see any questions. So I'll just say thank you so much for this session. I know tomorrow we have another session which will be going in a little bit more of a deeper dive. Tomorrow's session is the programming in Reach, which is going to be great. So I'm excited for that. That will be an hour and a half, and the session tomorrow starts at 9 a.m. EST. So feel free to join us, and we'll be more than happy to walk through that program with y'all. It should be another one to be a good one to kind of fiddle around with and try your hat at. So thanks again, Nicholas, for this morning, and we'll see you tomorrow.
Yeah, absolutely. Tomorrow's session will be a lot more in depth. We're gonna skip over the basics and we're gonna go right into the details. And we may build a full scale NFT auction by the end of it, or maybe it's an NFT raffle or something else cool like that. So please join us for tomorrow. So.
Oh, awesome! All right, cool. Great. Well, we'll see you then.
Thank you.
Bye, everyone. Bye, you guys.